Hello everyone, welcome to the lecture. Today's topic is optimization of basic blocks. There are two types of basic block optimizations. They are structure preserving transformations, algebraic transformations. First one, structure preserving transformations. There are four types. The primary structure preserving transformations on basic blocks are, we are going to perform transformations on the basic blocks. First one is common sub-expression elimination, dead code elimination, renaming of temporary variables, interchange of two independent adjacent statements. First one, common sub-expression elimination. Common sub-expressions need not to be computed over and over again. Instead, they can be computed once and kept in store from where it is referenced when encountered again. For example, A is equal to B plus C, B is equal to A minus D, C is equals to B plus C, D is equals to A minus D. The second and fourth statements compute the same expression. See, B is equals to A minus D and D is equals to A minus D. Both second statement and third statement are computing the same expression. So that these are called common sub-expressions. We can eliminate this sub-expression so that we can reduce the code. After reducing, we can get the basic block can be transferred to A is equal to B plus C, B is equals to A minus D, C is equals to B plus C and D is equals to B. Instead of writing A minus D, so we can write B because B is equals to A minus D, so that D is equals to B. And also here we need to find another point. After eliminating common sub-expression, we will find another common sub-expression, that is B plus C and B plus C. First statement and third statement. They are not common sub-expressions because after this A is equals to B plus C, before C is equal to B plus C, the B here, the second statement, B is updated. B is updated. The value of B in second statement is different from the value of B in the first statement. That's why B plus C is not common sub-expression. So that we should not eliminate this B plus C. Then dead code elimination. It is possible that a large amount of dead code may exist in the program, that is useless code. Eliminating these will definitely optimize the code. For example, there is a basic block B2, B1 and basic block B2. B1 will contain three address statements. A is equals to A plus 2, B is equal to B plus C. B2 will contain B is equal to B star C and C is equals to B plus 2. But this statement A is equal to A plus 2 will not be used in subsequent basic blocks. So that is dead code. So that we can eliminate this useless code. After eliminating this code, we will get basic block B1 as B is equals to B plus C. Basic block B2 will contain B is equals to B star C. C is equals to B plus 2. That is dead code elimination. Next, renaming of temporary variables. A statement T is equals to B plus C, where T is a temporary name, can be changed to U, that is U is equal to B plus C, where U is another temporary name and change all uses of T to U. T is changed to U. That is renaming of temporary variables. Why we need to change the temporary variable names? For example, T1 is equals to X star Y, T2 is equals to Z minus T1, T1 is equals to T1 star W. Here T1 is equals to X star Y, T2 is equals to Z minus T1. Here T2 is equal to Z minus T1, T1 third statement, T1 is equals to X star Y, T2 is equals to Z minus T1, Z minus T1, T1 is equals to T1 star W, T1 star W. Here T1 is equals to X star Y, here T1 is equals to T1 star W. What is T1? T1 is X star Y star W. Here the T1 is X star Y star W. Here the T1 is X star Y. That means here in the third statement T1 is updated. T1 is updated. This old value of T1 will not exist. But some other block in subsequent blocks, the value of this T1, that is X star Y, may be needed in future in subsequent blocks. So that we need to keep it as it is, t1 is equal to x star y. That's why we need to change the name of this temporary variable t1. That's why I will replace this code. T1 is equals to x star y, T2 is equals to z minus T1. This T1 is replaced as T3. The name is renamed, that is T3 is equal to T1 star W. W is equal to T2 plus T3. T2 plus T1 as it is. Here this T3 is T1 x star y star W. So this value is preserved as it is. This is also evaluated correctly. That is the use of renaming of temporary variables, preserving the old values of temporary variables. Next, interchange of two independent adjacent statements. Two statements T1 is equal to B plus C, T2 is equal to X plus Y can be interchanged or reordered in its computation in the basic block when value of T1 does not affect the value of T2. That means the value of T1 and does not affect the value of T2. That means T1 is not depending on T2 or T2 is not depending on T1. They are independent variables. So that if the variables or statements are independent, we will interchange the order. See, T1 is equal to x star y, T2 is equal to z minus T1, T3 is equal to T1 star W. Here this T1 and T2 are not independent because T1 is depending on T1, T2 is depending on T1, that T2 is equal to z minus T1. So that T2 need value of T1. So that T2 and T1 are dependent variables. Then T2, T3. T3 is equal to T1 star W. T2 is equal to W minus T1. Both T2, T3 will use T1, but T2 and T3 are independent variables. They are not depending on each other. So that we can interchange the order like that. T1 is equal to x star y, T3 is equal to T1 star W, T2 is equal to z minus T1, W is T2 plus T3. This is the interchange of two independent adjacent statements. You can interchange the order if they are independent variables. Algebraic transformations. Algebraic identities represent another important class of optimizations on basic block. This includes simplifying expressions or replacing expensive operation by cheaper ones, that is reduction in strength. For example, x, we are simplifying the expression x is equals to x plus 0. That means the value of, by adding 0 to x value will not be changed. So that we can remove this statement x is equal to x plus 0 from the code. Another example, x is equals to x star 1. So if you multiply x with 1, the value will not be changed. So that this statement also removed from the code. Another, the expensive operation may be replaced by cheaper ones. X is equals to y star star z, that is x is equal to y star can be replaced by a cheaper statement, that is x is equals to y into y. That is replacing an expensive operation by a cheaper one. Constant folding. Here we evaluate constant expressions at compile time. During compile time, the constant expressions can be evaluated and used further. Replace the here we evaluate constant expressions at compile time and replace the constant expressions by their values. For example, 2 star 3.14, 2 into 2 star 3.14 would be replaced by 6.28. That is constant folding. Thank you.